Right. This is Dr. Williamson wanting to fix a mistake that I made a couple times during lecture where I was having a major brain hiccup and I couldn't figure out what I was doing wrong when I was trying to use the Gibbs free energy of a reaction in equilibrium to calculate the equilibrium constant, and I was getting these crazy numbers, and I was making some kind of weird math goof that I couldn't catch. So I went over it and I went over it, and I think I found what I was doing wrong. So what I'm going to do is if you look on some of the previous notes, I went to take this reaction here, formic acid in water, aqueous, to produce the formate ion and hydronium ion. And I originally did that. And I originally did that, showing it reacting, showing the proton on formic acid jumping onto water or getting onto water, producing hydronium ion. And part of the problem is we weren't given the Gibbs free energy of hydronium ion, Gibbs free energy of formation of hydronium ion. We were given the Gibbs free energy of formation for hydrogen ion, which is zero. And so we use the Gibbs free energy of formation of liquid water in our calculations. And that's part of what was giving us crazy numbers. So what I did is I took that out because this equation here is equivalent to this equation. That's like my equilibrium symbol there. H3O plus. Okay. Where H3O plus is H2O. Liquid with an H plus on top of it. And if I subtract out this and I subtract out that, I'm subtracting out the Gibbs energy of formation of water on both sides. So I'm subtracting out the same number from both sides, and I can legitimately produce this. That's one of the beauties of Gibbs energy being a state function. So I can legitimately just deal with this. All right. So I'm going to move this back down to here. And I looked up the Gibbs energy of formation of these things. And I got delta G naught of formation of this was negative 335 kilojoules per mole. This was negative 356 kilojoules per mole, and this is 0 kilojoules per mole. And then the Gibbs free energy of reaction, standard Gibbs free energy of reaction, will be products minus reactants. And that's going to be um, let's see here. Hold on. I got my numbers backwards. This is negative 356 here. And negative 335 here. I was looking at my notes and looking at the wrong part of my notes. Okay. So this will be negative 335 kilojoules per mole minus a negative 356 kilojoules per mole. And I will get a positive 21 kilojoules per mole. And I'm worried about sig figs right now because I'm trying to teach the principle. When I rearrange this, that capital D is supposed to mean delta G, okay? Except in this whiteboard app, I couldn't type the Greek letter delta, so we're just going to understand capital D means delta G, all right? We're going to get K, when I rearrange it, is going to be equal to minus, or it's going to be equal to the exponent right? That means e to the power of negative delta G of reaction over RT okay? And I haven't looked up the true value for this, but it's going to be EXP. This is the same thing as writing E to that value. It just makes it, easier to write. So I'm going to write 21,000 joules per mole. R is going to be 8.314 joules per mole times, I didn't give a temperature, so we're going to assume 298 Kelvin. Oh, my minus sign, can't forget that. And when I do that math, that's going to give me E to the negative 8.48. And that's going to be K equals 2.1 times 10 to the minus 4. To the minus 4. Now I'm going to pause this for a second while I look up the real value. Okay. And then when I looked up the real value, see if I can do a print screen, if they'll let me paste. Paste. Ooh, have to make that bigger. So when I pasted out of the appendix, I got 1.8 times 10 to the minus 4, which is really close when you consider, I didn't go to as many, I didn't use all the significant figures and I rounded a bit and so on. So that's how you do it. I figured out what the mistake was. And, I hate making those mistakes and leaving them untouched or unresolved. Okay. Anyway, I'll post this for you guys. All right, then. I'll talk to you later.